Okay, so welcome to some new change timings. Unfortunately, because we're down to exactly just 1 hour, I can't really wait at all for anybody, so sorry, I'll always begin at 12:45. I will do my best to try and finish a little bit before 1:45, and I promise I will never go beyond 1:45 because I know you had to make it to the next class. I think we'll probably do okay because I think, as we've noticed, most of the classes usually finish about an hour anyway. All right, so I think we'll probably end up working out pretty decently. All right, the good news is we've already done this lecture because I kind of did it yesterday because I think it's probably more important to see nested data structures. However, I do need to go through this officially this time, and what I will do is I'll toss in a couple of extra exercises, and hey, if we finish early, then we finish early. So that's not too much of a trouble. So as usual, a couple slides first, and then we'll pop in to the interpreter and we'll look at things. All right, so nested data structures. Okay, ooh, there's something. All right, so we're covering a section called nested dictionaries and comprehensions, but we don't actually cover comprehensions. Give me half a minute because I have to show you what comprehensions look like so that you know never to use them. All right, so here we go. So this is not part of the course. Okay, so let me look for it this way. Python list comprehensions. All right, so we should be able to find a couple of quick examples of these things. Okay, so here you go. Here's an example up top. I hope that example is not a real big surprise. What they seem to be doing is going through a list of fruits, and they're adding all the fruits that contain the letter A to a new list using an append. Good. That's the stuff that we do in this course. Below is an example of something called a list comprehension, and it does exactly the same thing. But I hope you look at that and go, what? Yeah, that's exactly it. We do not cover these in this course, so that's a comprehension. So if you find something online and go, hey, cool, yeah, I can use that, don't. Okay, we do not cover these. Why don't we cover them? Because I know some people are going to say, hey, no, but they're kind of cool because it can do lots of stuff in a single line. Yes, you can certainly make a mess out of your program in a single line and not be able to solve the problems. Okay, that's it. If you're really good at comprehensions, yeah, you can shorten your code down so stuff that used to take 4 or 5 lines happens in only 1, but generally it's not something that we want to do. In a first-year programming course, generally we want to make sure that people actually understand logic and they don't just have, yeah, I learned a cool one-line trick which does something. So that's a list comprehension. Let's see, Python list. So if I come down to tuples, let's see if I find the same thing. Tuple exercises. Okay, let me try a dictionary. Did they have one? No, I'll have to do a search for it. All right, so here we go. Because it was actually called out, dictionary comprehensions. So guess what? Yeah, we're going to see. All right, fine with this. Okay, well, you know what? There's one right there. Okay. Not this one, but right there. Squares is equal to curly bracket x colon x star star 2 for x in range 1 to 6. Yeah, that produces a dictionary in a single line. Again, we don't cover these either, okay? I think it's probably more important that we learn how to use dictionaries. I'm going to call it in a simple way, so that you can solve complex problems rather than using a complex way that basically obscures everything. So, sorry, if you have used these before for the rest of this course, sorry, put them away. Once you're finished with this course, you can pull them back out. It's not a problem, but no comprehensions, okay? Because usually what I find is the students using them ended up picking them up from ChatGPT most of the time. So please don't use them. Okay, if you use them, it's no problem. I just give you a 0 on any assessment. So up to you. All right, so here we go. Introduction. Storing real-life data usually benefits from, unfortunately, the use of complex data structures. All right, so we've seen list of integers. Okay, yeah, that has some applications. We saw some dictionaries the other day, but you notice that when I didn't actually give you just a single dictionary. Well, eventually I did, but the thing that I started with was a list of dictionaries, because that made a lot of sense. We have a list of students, and a student is a complex object. That makes a lot of sense. And yeah, this is a concept of nesting. And real life, unfortunately, is complex. It's very rare that we have a simple dictionary that has a string as a key and a value, an integer as a value. It does happen, but they're kind of contrived examples. They're not things that we end up using. So being able to work with these complex things like lists of dictionaries and dictionaries filled with more dictionaries, this is the most common thing. And we had a list of dictionaries yesterday. I'll repeat a couple of the exercises, and then I'm going to give you also a dictionary of dictionaries, which is also really important, but we'll have to do a couple of steps first. All right, so first exercise that I gave, you know what, here, I'll even show the slides because, yeah, we saw it yesterday. By putting this particular storage down here, a list of dictionaries, why did we make the things inside the dictionary? We made them to prevent people from accidentally flipping things around. Okay, and yeah, so even if we took GPA and we put it at the beginning, it works completely fine. Your code continues to work, and your understanding, of course, also continues to work. And that's really important because if I point to this field right here, 3.7, it's absolutely no question what that is. That is definitely a GPA, and that is much better than people writing comments. Okay, yeah, it is, because remember, I've made the joke before about people writing comments. A lot of people don't do it, and when you have code that's written like this, yeah, it's not as important to put them. All right, so as I said here, list of dictionaries is a very common, useful pattern, and what you do is you have this when you have a lot of things, and each one of those things has a lot of properties. Okay, so in this case, we have a lot of students. Each student has a bunch of properties. It's really good for storing records, stuff that would come from a database. We use this all the time. Usually, you have to process it using a loop, okay, because you're going through and you're saying, okay, well, for each dictionary item, check something. In fact, I think we will do a few of these exercises. Let's see, okay, I think I've already said that's repeated, and often in processing involves, it's like I'm repeating everything. That's fine. All right, so let's get over to here and let's do some examples. All right, the first one that I did, okay, it's not bad. We kind of did one of these yesterday. So paste. Okay, we can make it a bit bigger. Okay, so sorry, it's just kind of off the edge, just so I make it big enough. And we wrote some functions yesterday. We wrote a function for finding the name of a student. Okay, that's fine, we did this. This particular exercise here, so I'll copy and paste. I'll steal as much as I can, so I can still type a few things. All right, so what this function is going to do is going to return a list of IDs representing the students that have a GPA bigger than 3.5. The list of honors students. All right, so what we're going to do, we'll develop this. So I know the code is here, but let's develop it because, well, again, you need the practice of seeing the process of creating it. All right, so first thing up, can I run this program as it is right now? Oh, in fact, here, let's go down and call it. What I'm going to do is I'm going to print academic honors. There we go. And I'm going to pass in the students as the list. Okay, when I hit run, what is going to happen? What am I going to see as the output? Why? Because the function needs to have something. Well, it does have something. It has a doc string. Okay, okay, it's the one place where you kind of get away without something. If I remove this, now we have exactly the error. Okay, all right. It's a trick question. Okay, so yes, with a doc string, your function is not complete, but at least it's not a syntax error. And because I didn't return anything, yeah, that's why it says none. You know what I'm going to return. I'm going to return this just to make sure it works. All right, yes, have I done any work yet? No, but I've set up my environment. Everything is ready to go. And remember, I've talked about this before. You see, sometimes people make a mistake and they accidentally misspell something because they didn't notice it. And trust me, this happens all the time. People are trying to run this and it's like, why is this not working? Okay, and if your function only has one line, it's usually easy to figure out what's going on. If your function has 20 lines and an if statement and a couple of loops, then you don't know where to look for the problem. Okay, that's why I write stuff like this. And as I've said, this is the approach that I use. All right, first step. Okay, I've got a list of things. Well, I almost always do this. I say, okay, you know what? Let's just start for each of these. Yeah, for X in student list, if we spell it correctly, print X, what do we see? Good, we see all the students. All right, well, I wouldn't call it X at this point. I'd use the letter I instead. What would be better variable name? I'm hearing student. Okay, I could call it this. Okay, for the lazy people, what's an okay name? ST would be okay. S I would even allow it to go, but not X, not I, not L, not A. No, make sure it's very clear that this is a student. I don't mind single letter variables, but they have to be, especially as loop variables, but they have to at least represent what you've got. Okay, ST, STU, student is okay. How about this? Student ID. No, because it's not a student ID. Okay, it's a student ID plus a name plus a GPA. So, okay, you could do that. Sometimes I end up with people calling it very simply like a student dictionary. Well, it's a lot of typing, and I mean, I guess it makes it clear. Whatever you would like, just make sure that it's not incorrect. Like the wrong letter definitely does it. Okay, so I'll be a little lazy here. I'll call it as in the slides, I called it student. All right, so do we see all the information, or do we have access to the information that we need? Okay, we're trying to make a list of IDs whose GPA is bigger than 3.5. Yeah, I can see a bunch of GPAs. Some of them are bigger than 2.5. Some of them are less than 2.5. But the problem is I'm seeing an awful lot of things. I'm seeing everybody. Maybe the first thing is I don't want to see everybody. I just want to make a decision whether or not the GPA is bigger than or equal to 3.5, and I'm going to print it, my next test case. Okay, and maybe you're looking saying, okay, run. What's wrong? Yeah, remember that down here, the GPA is spelled GPA with capital letters. And well, can we have both? No. Okay, you could have both. Okay, and is there something I can do with a 2 upper and so on? Yeah, but if you're doing this type of stuff, it means that your data is probably bad in the first place. Here's the rule about using lists of objects. All of the objects, dictionaries, list of dictionaries, get the right terminology here, sorry, it's for the other course. A list of dictionaries, all of the dictionaries inside the list should have the same fields. They should be spelt exactly the same way. What if they're not? It becomes a very difficult problem. And the good news is it's not really a problem that I ask in this course. Well, definitely not in an assessment. Maybe on a small lab question to try it, but not on an actual assessment. No, I will never give you this combination where some of the things are spelt this way and some are spelt the other way. I don't do it because that's not the way how data should be structured, and it's not the way that I structure data. All right, but in any case, yes, you would have to realize that, yes, this is really GPA. All right, now, do we see the people who should be on the honors list? Yeah, but the thing is I'm seeing too much data. I'm only interested in the IDs. Okay, so don't print the entire thing, just print the IDs. So how do I print just the IDs? ID. There you go. That's the IDs. Of course, that's just printing. The function is supposed to return a list of IDs. Exactly these IDs, but it's supposed to return it as a list. Well, how do you make a list of a bunch of things? Because remember, right now this is inside a loop. It's the same process we used last time. It's the same stuff we've been doing in the lab the last couple of weeks. You have some kind of a structure that you start off with absolutely nothing, okay? And down here, instead of printing it, yeah, you append it to the collection. So you append the SID, and if you want to stick that into an extra variable called student ID, that's fine. Okay, so here you go. Yeah, I don't need to print anymore because now I'm appending it. And at the very end, and of course you don't return it right away because you might find more, you return the you return the result. Okay, there you go. Now there's the list of students, student IDs who show up on the, what do we call it, the honors list. Okay, there we go. You'll notice that same pattern shows up over and over again. Have a result sets equal to an empty list, iterate through, find what you're looking for, append the things that you want, return it at the end. You'll see this a pile of times. And I would say if you memorize this one, you keep practicing this type of stuff, almost for sure you'll have a lot less issues. Okay, so there we go. There's the first one up. Okay, what do I have next one? Next one is finding a student finding a student GPA by an ID. Okay, so here we go. Let's trash this one, just so we don't use up too much space. And this function right here. And I want to try a couple of different ways for it. Okay, so here we go. Whoops, not supposed to see that yet. All right, but obviously we'll get there. All right, so this one right here, this is find the student GPA. Let me be a little bit lazy. The way how it works, you pass in the students and you pass in the ID. Okay, now this should be piles and piles of fun. Here we go. So when I run this, I should see, let's find out what we've picked. Okay, 3.8. Okay, that's this person's ID. When I run this, will I see 3.8? As written right now, will I see it? No. What am I going to see? Blah, yeah, because that's all I'm returning. Okay, because we haven't actually done the work yet. Okay, so let's work it out. All right, step number 1. Okay, oh, remember what we're doing. We only want one. Okay, we don't want a whole list of them because there's only one student. That's a different approach, but we do exactly the same thing we've always done. You set up a loop, you iterate through everything. So maybe for S in student list, print S, because I just want to find out, is this working? Am I calling the data, or am I calling the function correctly? Am I passing in the right stuff? Do we see all the students? Yes, we do. Do we see the student I'm interested in? Yeah, the student is definitely there. All right, next step then. Okay, if. Okay, so what we're going to do is we're going to ask for if S's ID happens to be equal to the student ID, I'm now going to print S. Okay, all right, so when I run this, okay, other than we're going to see a blah at the end, should I see the student? And the answer is yes, I should see the student. But we didn't see the student. But we know it's there. Okay, just double check. 6030-6030-7890. Okay, at this point, you start to become desperate. Okay, honestly, I mean, I get desperate with these types of things as well. All right, so how do I deal with it? Okay, when we put a print statement here, it's working. Okay, let's be really, really precise about this. This is honestly sometimes what I will do if I'm really stuck in a problem and I don't have access to something called a debugger. Unfortunately, we don't cover the debuggers in this course. It's sort of too bad because I think it's really important, but I believe the idea is that people are supposed to reason their way through things. Basically, we make your life miserable so that you learn how things work so that when you get a debugger, much easier. In the absence of a debugger, here's what I will often do. I will print S at ID, and I will also print student ID because this is what I'm about to comparing. About to compare, not to comparing. It's terrible English. Here we go. So what I'm going to do is I want to find out what are the values. Why is that if statement not triggering? All right, so here we go. You see, I compared this one to this one. Are they the same? No, so it makes sense that I didn't see it. This one to this one, not the same, so it didn't print. This one and this one, are they the same? How come it isn't working? Okay, so here we go. We got one extra thing that's going to become kind of important. Print comparing, and I'm going to copy exactly the same thing, but I'm going to add one extra item in here. Do you remember the little operation called type? Okay, what does it show me? It shows me the type of the item. So here we go. Let's put it down here. All right, and run it. All right, now let's look very carefully just at this one right here. This is the one that was of interest, that we think should have worked. But take a look at the comparing. I tried to compare a string to an int. Yeah, and guess what? The string is the string containing the letters 60307890 is not the same as the integer 60,307,890. And that's literally what we just tried to compare. That's why this failed. This is something that can burn you if you're not careful about things. You see, the issue is whoever passed this in forgot to put the quotation marks around it. Oh, nobody told me about that. Actually, I would have told you to ignore it for right now. All right, so at this point right here, now I can remove my debugging information, and yeah, now I'm down to it. Okay, you see the process that I use? Show everything, filter just what I'm interested in. If that's not working, then something's wrong. Figure it out. Don't try to return it. Don't try to build lists. Just figure out what's gone wrong before we do anything else. All right, at this point right here, what are we supposed to do? We're supposed to return the GPA. Okay, so S at GPA. Oh, sorry, GPA. Okay, spelled this way. All right, so bang, there you go, it's 3.8. But there's two returns. Well, remember, first return happens, end. The first student is looked at, not it. Second student is looked at, not it. Third student was looked at, that was the one, it's returned. The only thing that I will have some issues is if I ask for something that isn't there, it currently says blah. Usually you wouldn't return blah, except in my course. Normally most functions in Python that if you want to indicate that something isn't being returned, normally you use the word none, or the type none. All right, don't worry, you don't have to make these decisions on tests because I tell you this is what's going to happen. Okay, it will say return just a GPA, and I'll even give an example, and if you don't find a student, return none. Okay, and that's it. So that's the none. Just remember that that does not mean none. Okay, it means something very, very different. It means a string containing N-O-N-E. All right, but that is actually none. Okay, and of course, why are we doing this? Why returning these things in the first place? Okay, here's the thing that we don't do very often in the course, and that is going to be, okay, I won't do it very often, input, enter student ID. All right, so I'm going to ask for a student ID, and I am going to pick up a value. So I'm just going to call it GPA, and I'm going to say, instead of asking for this hard-coded value, I'm going to ask for the thing called toFind. Okay, so here we go. Oh, sorry, I don't need one of those now. At this point right here, I'm just going to say student's GPA is, and GPA. Okay, I got too many. Sorry, I'm used to putting 2 at the end. All right, so if I pick like a 60305678, bang, there you go. The student's GPA is 1.5. Yep, that is. But unfortunately, if I type in some other random stuff, it says that the GPA is none. Perhaps a different message would be invalid student ID. So how do we make that decision? We ask the following question. If GPA is none, there's actually a few different ways how to do this. Student not found. Okay, otherwise, print this. There we go, student not found. Okay, so this is how we use is none. Okay, that's why we return these things. So let's see, let's put this away. Next statement. Okay, next page. Okay, oh, here we go. So something great fun. Okay, so get the idea of a list of dictionaries. Very, very common things, okay? List of dictionaries all the time. When we do this stuff on file input later, when you read contents from a file, it shows up as a list of dictionaries. When you make a connection to a database, which maybe eventually we'll start to do this in the database course, you get back a list of tuples. But you can set it up to give me a list of dictionaries instead, and it's actually much easier. All right, so yeah, a list of dictionaries, very, very critical. All right, next one up. Okay, we've got this second thing here, which sounds really, really terrible. Okay, you get the idea. It's a list, and inside each is a dictionary. For some reason, I have gone and I have stuck up this title slide called a dictionary of dictionaries. So what this means is that you have a dictionary, and inside the dictionary you have a whole bunch more dictionaries, and the answer is yes. Okay, why would we want to do this? Well, the reason why we want to do it is because it actually makes a lot of programming a lot easier. Okay, but obviously I don't want to talk about it from here. Probably going to be a lot easier if we go off and we look at an example. Okay, so first thing up is out with the old and in with the new. There we go. That is a dictionary filled with dictionaries. All right, so how do I know it's a dictionary? Well, because it's got curly braces. How many entries are in the dictionary? Because that's the first question. Well, there are 1, 2, 3, 4, 5. Okay, it doesn't have to be 5 lines. Remember, I've done this before. It's still 5 entries, just sometimes a little bit easier to read. I will push enter just because my font's a little bit big, just so I can see it. That way we can see the GPAs as well. All right, so there are still 5 entries. Every entry happens to be a string, and of course, what's the entries? Well, it's exactly the student ID. Okay, that's fine. And what's the value of each dictionary? Well, the value of each dictionary is a dictionary. Okay, and what's inside that dictionary that I just highlighted? Well, it's got a name and a GPA. Okay, why on earth would we do something like this? All right, here's some really cool stuff that you can do with it. I'm going to do this without a function first, okay, just so that we understand what's going on. All right, first thing up, if I said print students, I will just see absolutely everything. Okay, it's a dictionary, and inside we see all the dictionaries. But here's the really interesting thing. You see, with a dictionary, if I were to pick something like 60302345, you see what I'm doing is I'm saying to Python, go to this dictionary and get me the value that's at that location, given this key. And what do I get? I get exactly 1 dictionary. Okay, now here's the really powerful thing with this. Let's go back and do the function once again. This function right here, find student GPA, given the student ID. Okay, I'm going to do the same thing as before. Temporary placeholder, let me get things set up. I'm just going to do print. Okay, I'm going to call the function directly, find student GPA. I'm going to pass in the list of students, and I'm going to pass in 60305678. All right, when I run this, I get the usual thing. I just want to make sure it's okay. What should this show? Don't tell me, no, come on. Look, the function is supposed to get a GPA given an ID. Okay, so, I mean, I can write up the doc string if you want. Okay, so what GPA should show up? What do you mean everything? Come on, look, okay, I'll have to write it then. Okay, this function is used to find the GPA for 1 student given their ID. I hope I don't have to type more. All right, so if I call this function with this, I know it doesn't work yet, what should appear when I run it? Yeah, okay. Will I actually see the words the GPA for the student? No. What will I see? What am I supposed to see when I run this? Excellent, 1.5. Okay, good. That's what I'm looking for. All right, when it was a list last time, what did I do? I went through and I iterated through all of the items. I printed everything, and then I said, okay, let's use an if statement, and we printed just the one that I was interested in. Then I finally just returned the item I wanted and nothing else. Okay? Okay, so in other words, yeah, we needed a for loop. But Watch this. You see, I can get the student details by going to the student list and simply giving the student ID, print student details. Because remember how this works. You're given a key, and you just look it up using the square brackets. Take a look what happens. I didn't need a loop. Now that's actually pretty cool because I'm sure everybody who writes stuff doesn't say, cool, I get to write a loop, right? Why? Because that's always the hard part. I bet 1101 was pretty easy until they introduced loops. I bet this course was pretty easy until they introduced loops. Okay? Yeah, it's the loops. Why? Because you're looking for the patterns. And these are things, of course, that you got the values that are changing, but the code has got to be written in such a way that handles all the possible cases. And look at this. We just got rid of a loop. We found something, and we didn't need a loop for it. Yeah, it just went there and it got it directly. Sounds magical. Yeah, actually, there's some really cool stuff that goes on. Here, let's switch it. We'll put this one right here. This time, we should see the 1.9. Yeah, there we go. Again, no loop. Okay, really cool. So I don't want to print it. What I want to do is I want to return something. I just want to return the GPA for the one student. Okay, well, to return a GPA for one student, all I would have to do is just go to the student details and ask for the GPA, because we already know it's a dictionary inside, and there you go. That's the end of my function. That was way too easy, wasn't it? Okay, well, almost. There's still a catch, however. Okay, the catch is, what happens if I do this? Okay, now I know the docstring doesn't describe it, but right here, does that student exist? No, because there's no keys over here on the left-hand side. So based on what we talked about before, what do you think the function should return? I'm not saying what does it return, what should it return? What's a good option? None. That would be perfect. Unfortunately, when I run this, it doesn't return none. It produces a key error. And it produces a key error because, well, the student with that ID doesn't exist in the dictionary. Oh, and now we're back and now it's hard. Well, it's not entirely terrible. There are a couple of things that you can do. Like, for example, do you remember I showed you yesterday, just at the very end, that there's an alternative thing called get? And that kind of worked the same way, except what happens is when you don't find the student, instead of, here, what I'm going to do is I'm going to print the student details before we do anything else. You see, it returns the value none. Oh, perfect. So in other words, what I can do is I can make a decision like this. I can say, okay, if student details is none, I can return none. Otherwise, I will have the student details and I know that there's going to be a GPA there. Okay, there we go. So now it returns none. And if I go for something like this one, there you go, there's a 3.2. The example that I gave in the slides is a little bit different, so I may as well include this one as well. Here, I'll even just copy and paste it so I don't have to type it again and make a mistake. There we go. So see what I did was I said, okay, if the student ID is in the student list, return the student list at position ID. Oh, I even cut it down and I just returned the kind of like a nested list. And I used 2 square brackets in a row. Yeah, you can also do that. And if I ever make the line number 8, that means that, well, the student didn't exist in the first place. So there you go. There's a 3.2. Here, we'll try a few. Okay, here we go. That is the first student, 3.6. And that number right there doesn't exist, so it returns none. Okay, but it is kind of cool. And it's cool because you don't need to loop through it. Okay, yeah, it saves you the loop. However, you have to watch out because you have to make sure that the item exists. If it doesn't exist, you might have to do something special. That's the thing you have to hang on to or keep in your mind. Yeah, if it doesn't exist, I need to have the special case to make sure that I don't accidentally try to return something that's there, because the last thing I want when you're running a program is to end up with a key error. Key errors are runtime errors and the entire program crashes. Again, we've talked about this before. Imagine that you're working in Microsoft Word and, I don't know, something happens and a key error gets generated. Yeah, Microsoft will crash and all of the work that you're currently working on and forgot to save, it's all gone. Yeah, you do not want runtime errors to happen. Okay, yeah, there's things you can do to prevent them from happening, but we don't cover here. Okay, next one up. Okay, excellent. So we have this, but now I'm going to create a really, really bad and unfortunate problem. Okay, so let me grab this one piece at a time. Okay, and find student GPA. I guess I didn't even have to change that. All right, here's what I want. You know, sometimes we end up in situations where somebody doesn't know the ID. All right, you just know the name. Okay, sometimes on the attendance sheets, I can't read the ID numbers. I know it's supposed to be easy, but sometimes I can't. And what do I have to do? I have to go look at the name and then do a search and hope I find it. Okay, thank you. Most people are signing or at least writing their ID so I can read them. But it seems reasonable that I should be able to find something using a name. So let's go for it. Let's actually pick out this name right here, and I would like to have a function that would find the GPA for the student given the student's name. So does the student exist in my class? And the answer is yes. What's their ID? Or sorry, what's their ID? Well, what's their GPA? 3.2. This is what we're going to hope would happen. When we run this, we would hope for a 3.2. Okay, obviously, yeah, we just get our placeholder. Okay, now here is going to be a bit of an issue. All right, so remember a couple little things. All right, x is equal to student list student name print x. What do you think? I mean, it worked a few minutes ago. That's what we did. We passed in. We simply used the second parameter as a key. But that's exactly it, because it will come back and it'll say, I couldn't find the student because there's no student with the key called Amina space al-Obeidli. Okay, we have student IDs as keys, but we don't have student names as keys. That's the problem. So therefore, it's an impossible to solve situation. Not impossible, but unfortunately, more work. Okay, so here's the deal. If you need to find something by a key, it's really easy. You just use the key inside the square brackets, done. If you need to find something on the value side, unfortunately, it's really quite annoying. That's probably the best way to describe it. And yes, it's also possible that you might end up with two students with the same name, and that's not being addressed here. Let's pretend that no two students have the same name for right now. All right, so how do we find it if we don't have access to the key? If we know the key, it's easy. If you don't know the key, it's possible, but it requires work. When you don't actually know the key, hey, that was cool. To figure out what button I pressed, that was really helpful. But here we go. If you don't know the key, unfortunately, you have to look at all of the values. When you take the database course next, I want you to remember that statement. I know you won't, but in the database course, you'll talk about things being primary keys or not. Primary keys for a database make finding things really easy. If you're looking for something that isn't a primary key, it's a real pain in the neck and it's slow. Okay, that's for the next course. All right, and here's what has to happen. If you're looking for something that's in the value side, you have no choice but to iterate through everything. So here we go. For x in student list, print x. Let's see what we've got. Do we have all of our data? Oh, no. What are we seeing? We're seeing the keys from the dictionary. And that's what you get when you use a for loop on a dictionary. Okay, so that's not helpful. I mean, I could maybe make use of this, but there's some other really cool things that I can do. And I remember showing them, it was a slide. Do you remember that there was an operation called .values? Okay, if I show you what's inside the values, now we can see the information we're looking for. Do I see the name that I'm interested in? good. Do I see the GPA for that goes along with the person? And the answer is yes. So I have my problem sort of half solved. All right, what do you call this? Because it obviously shouldn't be X. Okay, I'll call it ST for student this time. All right, here we go. So here's what I'm going to do. I'm going to say if ST add name is equal to the student name that I'm interested in, I'm going to print it. Somebody should have yelled at me. Here we go. Student name. All right. Do I see the student I'm interested in? Yes. Do I see the GPA that I need to send back? Yes. Okay, perfect. So in this case, the only thing left is return ST's GPA, and that's the end of my application. Obviously, instead of returning blah, I would probably return none. That's the case at the end when nothing is found. Okay, excellent. Now, I would like to change the problem. The problem I don't believe is in here, but it's so closely related, and I think we were doing okay for time. Yeah, good, that's fun. That's it. Okay, cool. That's going much faster, which means I pull out the next example too that isn't in the slides, but it's also kind of a cool thing. We can try a couple of things. This way you get an idea of the nested structures and how you can use it. All right, I'd like to change the method a little bit. Or sorry, the function a little bit. Sorry, if I ever use the word method, that's from a different course altogether. So teaching too many courses with too many languages. Okay, put it back here. All right, here's a real problem. You're trying to find an ID and you don't have the student ID, but you have a name. Can I do it? And the answer is yeah, I can do it. There's things in PeopleSoft that allow me to do it. But what I have to do is I have to take like a kind of a guess about how the person's first and last name are spelled. And I have to provide at least a few letters and it'll give me everything that matches. Okay. Okay, so that's kind of it. But anyway, here's the idea is given a student name, I want to be able to find the ID. So in other words, when I run this program, I would like to see 60302345 because that's the ID for this student. Okay? All right, so now the thing is when I'm searching for it, am I going to be able to use the key directly? And the answer is no, because we already know we're searching on something based on the person's name. The person's name shows up in a value. All right, so we have an idea that it might look something like this. So I will repeat it again. For X in student list, print X. Okay, I know I'm repeating this. Do we see the information we're looking for? Well, we see some stuff. But the thing is, we see a bunch of IDs, but we don't know who it belongs to. Okay, all right. What we did a few seconds ago is we said, okay, if we include the word values, I now see the name of the student that I'm interested in, but unfortunately, I don't see their ID. Yeah, so, oh, it's one or the other, but I need kind of both. All right, and if you remember, I showed you another thing called items. And items is probably one of the most convenient things that we deal with whenever we're searching through dictionaries for items, because it shows you both the key and the values. Do you see the information that you need to solve this problem? I'm not saying about Python, because if you can't see it, guess what? You can't make Python get it. Can you see the answer? Yeah, you can definitely see the answer. If you can see the answer, then you can code it. All right, so what do you call this? It's not X. Okay, now, this is a little bit funny, okay? And I'm not saying that it's completely incorrect. Is this really a student? Well, kind of. But you see, it's a tuple that consists of two things. It consists of a student ID and maybe some details about the student. Yeah, that's really the two things. Oh, but they are showing up as a tuple. And I hope you remember something from, I guess, a week ago. I called it tuple unpacking. You see, the very first thing is really the student ID. The second part is the details. Okay, so ST add ID, ST add details. Take a look at this. You see, I've now separated, I now have two variables. I have a variable called stid, which contains just the ID, and then I have another part, the second part of the tuple, which contains all of the other details. But now, because I've got this, I can now start asking questions. If stdetails name happens to be equal to, and I'll spell it correctly this time, student name, and only print this. You see, now I'm down to only one record. The only thing left to do is to actually return something. What am I supposed to be returning? Just a student ID. That's it. Oh, so we use the details, but we never return. Yeah, that's fine. We use the details because we know that the name was in the student details, but I was just interested in the student ID. But I had to kind of iterate through, well, both. Yeah, this is actually the reason why this thing called items exists. There are things you can do to avoid using it, but I don't really want to cover it. Now, I know that I'm supposed to cover something else, and I didn't add it to the records yet, but I don't think I want to go out on a limb right now. Okay, maybe I'll bump into it as an example another time if we have extra time, but I think it might be covered in the labs. Okay, so I will leave it out, but I know there's a slide missing from here. You're not going to be asked questions on it, I'm just missing something. All right, so here we go. Yeah, that was not bad. We got 15 minutes. Yeah, we're not gonna, sorry, I'm not gonna let you go yet. We got more stuff. Okay, give me a second because I thought of another kind of a cool item. Oh, I know. No, we'll do that in a few seconds. Okay, so I promised like 10 minutes and I think I'll probably be done. All right. It's a bunch of data. Okay, let's see if we can make up what it means. All right, first of all, well, it certainly says students. So it certainly looks like there's a whole bunch of students, and we can see here that there's a bunch of things that look like student IDs. I just asked ChatGPT to generate these. All right, but what are the values of each student? Okay, it's a bunch of ones and zeros. All right, here's what I was trying to do with this. I thought this might be kind of fun to do some analysis on this, and here's what the numbers mean. 1 means a student was present for a class, and a 0 means they were absent. This is an attendance thing. Okay, yeah, it's not the way how it's done in PeopleSoft. It's just an idea without kind of overloading you. Does it make sense that I've got a list of values after each student? Yeah, because, well, look at this. I mean, every student, apparently there are 10 classes. Okay, maybe there's only 10 classes in total. Maybe there's only been 10 classes recorded so far. All right, so let's do some stuff. Let's calculate, or we'll write some functions so that we can figure out how many, we'll try a bunch of things. We will figure out how many classes the student has been present in. We'll even calculate their percentage of absence. Okay, given an ID. And for fun, we could even ask how many students have been here for more than a certain percentage afterwards. Okay, and again, if we have time. So yeah, we've got 10 minutes. Sorry, I can't let you go because the more practice we have, the better. All right, so let's write some functions. Okay, so a fun one might be, okay, how many absences? Okay, count absences. All right. Counting absences, I don't mean for the entire class. Most of the time, what you would end up with is some data. So I'm going to call it data. We'll call it attendance. Yeah, I know it's called students down here. I always keep it separate. The second thing is we'll keep it as the STID, which is, of course, the student ID. All right, so return, yep, as usual, blah. Let me write a doc string so that you have some idea what I'm trying to do. All right, so returns the number of absences for the given student ID. Okay, so it's a count. So in other words, if I asked you how many times was this student absent, your answer would be 2 because there's 2 zeros. Okay, excellent. All right, so here we go. I can come up with a couple of cool ways to do this too. All right, so here we go. That's what I want to return. All right, so well, let's start. Start with the simple things, by the way. Oh, and just as a warning, when you get into things like the lab exam and even the midterm and the final, you will see things that the spec will go on, it'll say do this type of thing, and it will say what happens if there are no students, what happens if the student's not found, what do you return? Okay, because there will be specs on this. Don't worry about those cases at the beginning. Deal with them at the end. If you try to solve everything at once in a single pass, that's always a guaranteed way to not do very well in the course. All right. First of all, is it easy for me to get the information? It's in a dictionary. Do we know the key? And the answer is yes, because it was given us a parameter. So that makes it very, very simple. All I have to do, let's call it records. That's for everything. And I'm going to pull out an attendance record. I'll call it attendance, ATT for attendance. I'm going to go to the attendance records, and I'm going to ask for STID, and I'm just going to print ATT. Okay. Didn't do anything. Yeah, I didn't call it. Okay, I guess it would make more sense if we actually did something. Okay, print, count absences. Okay, I need to pass in the list of students, and I need to pass in somebody. So we'll pass in, all right, you know what, we'll pick the very last one, because that's the most interesting one, because it shows up at the very end, and of course, it's the list you'd have to iterate through. All right, so here we go. We know it's going to return blah. Is that the attendance record for that student? 1010110. Yeah, that's the attendance record. Okay. But it should be counting. Yes, that's right. But right now, we don't care about that. We're not done. Once we're done, then we'll return it, and then we'll count. Okay. Well, now let's count it. Okay, so num absence. Okay. What do you think? Counted loop? Really, somebody wants to do, okay. Num absences is equal to 0 for, okay, for A in ATT, print A. Those are the numbers. What I could do is, I could say this. If A is equal to 0, then num absences goes up by 1. And then I could return the num absences. What do you think? Seems pretty reasonable. How many absences are there supposed to be in this student? There should be 4. So will he get a 4? Yeah, we'll get a 4. Yeah, that's fine. Could I do this a little bit easier? Yeah, probably. I hope you remember that there's an operation called count. Okay, and the way how it works is you pass in what you're counting. That also gives this. You could also count the ones. Okay, just to make sure that it's working. That's obviously, I just want to make sure it was actually going. Yeah, you're counting the zeros. Okay. Here's another, a different one, just because we've got it. What do you get if you sum all the attendance records for that student? You wouldn't get the right number, right? But what would you get? No, you get a 6, right? So this one right here. Basically what you're doing is you're counting the presents. Yeah, okay. Oh, but I want the absences. Okay, no problem. The absences would be the length of the attendance minus the sum of those. There you go. There's another way. Which one's correct? They're all correct. Okay. Whichever way you want. Even the first one iterating through. Yes, I would never ask for questions and say, no, you must do this. No, I don't ask that. It's, okay, here's a problem. Solve the problem. All right, does this work in all cases? Well, here's one particular case. How about that? Probably not. What's the absence count for a student who doesn't exist? Yeah, okay. What do you mean an error? We've got a function here. We're supposed to return something. We're not supposed to just crash. Okay. Very common thing. None. Yeah, I mean, it's a very common thing we'd end up doing. But the issue is, which line did the problem happen on? Give me a line number. How can you tell? Because it says right here. Yeah, those errors aren't just like, oh yeah, oh there's an error, okay, now let me figure out. No, actually, look, it will tell you exactly where it was. It was line number 6, which means that you'd have to do a check beforehand. You'd have to find out if STID not in attendance records, then you could return none, and otherwise you just let the rest of the program continue, okay? And by the way, this is often the way how I write functions is if you know that you've got a problem, check for it up front. All right, so there we go. There's the counting absences. Okay, let's count, or let's work out the percentage, because that's obviously really important, right? Okay, so counting the absences. Okay, maybe it's all right, but the absence would be the absence rate. Okay, that's fine. Here, let's go back. We'll make it so it's a legit student. That's just more difficult. Here, go away. All right, another function, def absent, or compute percentage, because I guess that's kind of important these days. All right, this is the attendance records, and we're looking for an STID, okay, and return once again, blah, and don't worry, this will be our last thing. I see you've got 4 minutes. We can easily finish this. All right, so here we go. This is going to calculate the percentage. How do you calculate a percentage? Well, you need to figure out how many times they're absent and divide by the total number of times. Okay, so how do you calculate how many times they've been absent? So the ABS count, oh, we've got a function right here called count absences, attendance records STID. There you go. If you have a function, you can call it. You're allowed to do stuff like this. That should give me the absent count, and we've already checked it. We don't have to write all the code again. We don't have to put in the nuns and so on. Yeah, use a function. That's the reason why we make these things. All right, and the only thing we really have to do is return the absence count divided by, oh, divided by what? Total classes? We're missing that one. Total classes. At length, but the length of what? We don't know this. So how about this? Count classes. What, another function? Yeah, absolutely. Attendance records, STID, and you know what? I'm going to basically steal a bunch of this work. And somebody just said, hey, yeah, the length. So this is going to be count classes. Let's do this. All right, so there's nothing, okay, don't worry about that case for right now. Yeah, the only thing you probably really want to return is just the, there you go, the length. There we go. The length of the ATT. There you go, that's the length. Here, I'll close up. Normally I like to leave extra space, but just to try and keep it as small as possible. There you go, so count classes. Okay, I just wrote another function for it. Okay, why are you writing so many functions? That's the whole idea behind writing functions, to help decompose a problem into smaller pieces. It's decomposition stuff again. Yeah, so count the number of absences, count the number of total classes, and return the division. Okay, so total classes. Okay, how do we do? 0.4. Okay, it's 40%. Okay, oh, don't like that one? No problem. Yeah, multiply the whole thing by 100. There you go. Now it's at a percentage. Okay, so student, AF definitely. Okay, a couple of important things here. I've included a couple of things kind of on purpose, and I will be done. All right, first one up is, yeah, I think you see the idea about why you might have a list inside a dictionary. That's kind of the simple case. Does this happen often? No, because this is kind of a, I'm going to call it a fake example. It works. We tend to see more like what I showed you at the beginning, which was the dictionary with the dictionary inside it, or a list of dictionaries made a lot of sense. I wrote a couple of functions. In fact, I wrote a whole bunch of functions because I just want to remind you that, yeah, functions aren't here to actually make your life difficult. It's actually to make everything easier. Notice that each of these things are very, very small. This is just counting absences. This is counting the number of classes. This is computing the percentage of things, computing the percentage based on these other items. And yes, those items or those functions call other functions. Yeah, we do this all the time. As I say, it's all about decomposition. When it comes to assessments, I usually don't get you to write functions I call other functions. Okay, so you would simply say, okay, give me something to compute the percentage, and I wouldn't expect that you'd write 2 extra functions. Every now and then I get a student who does it, and it's completely fine. I don't encourage it, I don't discourage it, it's just, yeah, it's allowed. Okay, sorry about this. I will now be quiet, and you guys have to run because you have a